Hello, welcome to an inspiring math video. I am Francisco Pedro. In this video, I'll be sharing with you distance time graph. Here we have a little diagram that shows the x-axis and the y-axis. On a Cartesian plane, this section here is known as the first quadrant, quadrant 1. Okay. Now the distance is in the y-axis and the time is in the x-axis. So distance time graph. As the object is moving, we notice that it's covering a certain distance and time is elapsing. In this case, traveled 15 kilometers from a specific time here to 10 o'clock in the morning. So if you notice here, we have to the center we have 8 a.m. So in the middle here we should have 9 a.m. This is supposed to be 7 in the morning. Then the question mark is for none other than 6 a.m. So this journey began at 6 in the morning and ended at 10 o'clock. Okay, so if you count the amount of hours, we notice that we have 4 hours for 15 kilometers. So we want to calculate the average speed. We want to focus on the speed that the object was moving. So first of all, we need to identify the distance, which is 15 kilometers, the time, which is 4 hours. The speed is made up of distance over time. So distance is 15 kilometers all over 4 hours. 15 divided by 4, 3.75 kilometers per hour. Here we have a second scenario. In this diagram here, we have distance time graph once again. Distance time is always in the x-axis, and the distance is in the y-axis. Here we need to calculate the speed. So first of all, the distance is from 0 all the way to the top here is 30 kilometers. The time from 9 in the morning to 11 in the morning, so that's 2 hours. So speed is made up of distance over time. So 30 kilometers all over 2 hours. So our answer here is 15 kilometers per hour. Now in this scenario, we have Peverell cycling day. At what time did Peverell leave? At what time did he leave? Well, if we consider the different unit of time that is provided here, 9 o'clock is here. So if we count by 1 hour, we note that it is 10, 11, 12 o'clock, then 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, and then 7 o'clock, 7 p.m. So let's go in reverse order here. We will have 8 o'clock, 7 o'clock, 6 in the morning. So that will be 6 in the morning. That's very important here. Now, how far did Peverell cycle? Well, the highest point here is 36 kilometers. That would be the distance. Okay, that would be the distance. And of course, down here is the time. So if we want to calculate the speed at stage A, let's consider this initial stage A. So remember then that the distance is 36 kilometers and the time in this case would be 1, 2, 3 hours. So distance is equal to 36 kilometers. Time will be 3 hours. So speed is made up of distance over time. Distance would be 36 kilometers over 3 hours. 36 divided by 3 gives us 12 kilometers per hour. Now we need to calculate at stage B. We want to calculate the speed at stage B. So if you notice once again, that is 36 kilometers and that began at 1 o'clock. So from 1 to 7, how much time is that? So we can do 1, 2, 3, 4, 5, 6 hours. So keep that in mind. 36 kilometers and 6 hours. So distance is 36 kilometers once again. The time is 6 hours in this case. So the speed at stage B, distance over time, 36 kilometers all over 6 hours. And that gives us none other than 6 kilometers per hour. So this is calculating the speed using distance time graph. Now, this horizontal section here, question mark, what do you think happened here? Starting at 0 kilometers, going up, movement, change in time, but here, the distance did not increase, it didn't increase nor decrease, but the time elapsed. Therefore, we can establish that here, the object was at rest, the object was parked, okay? So it remained constant, remained in the same place. All right, so this is the scenario for distance time graph. I hope you enjoyed it. Thank you for watching.